Welcome back to Desk Careers, everybody. I'm so excited to have another amazing guest with us. Today we speak to Sayeed Khan, who is an aeronautical engineer focusing on the aircraft industry from manufacturing to maintenance and training. Not only does he have experience as a lecturer, he also has experience in the industry, including areas of military and commercial work as well. Welcome, Sayeed. Thank you for joining us today.
Thank you. Thank you very much for welcoming me.
It's so exciting to have you here and the wealth of information that you're going to provide for us, not just in industry, but also talking a little bit from the perspective of a student learning to be an aeronautical engineer is going to be so inspiring for our students. Now, before we get into what you're currently doing, I'd like to take you back to your younger years, the younger teenage Sayeed. Do you remember the academic interests that you had when you were a young teenager?
Yes, when I was a young teenager, my interest was to break the toys and find out what is inside, what's the machinery, what makes it move. So I started as a kid like that, and as I grew and came into the high school, then I realized that to be an engineer, you need to have mathematics. And from the high school itself, I started working with my math. So math was the one which was required for being an engineer. And since we had been traveling by air from childhood, so I had a fascination for aircraft. So I chose aeronautical engineering, did bachelor in mechanical and then master's in aeronautical engineering.
So going back to building those and breaking those cars and toys and seeing what's on the inside, who would you say would have been the role model along that time? I know you said that you were fascinated with the aircrafts because of air travel, but who was the engineer in the family, or was there, that got you thinking more about building and breaking and rebuilding?
Yes, my uncle, he's a mechanical engineer and he works for power generation. So I had seen him going to the sites and looking into the power stations and a lot of paperwork and load shedding, etc. And he was always busy, always getting calls and continuing with his work. So that fascinated me. I thought as a child, it's an important position. So I wanted to go into an important position, and I thought it should be more than this. So I chose aeronautical engineering.
What about when you left secondary education? What was it like to study engineering at that time?
I did what we have now, the O levels and A levels. And when I went out of my school, I had A levels. Now A levels grades these days are very high grades they have got. But when I studied, those days somebody gets a 70%, 80%. It used to be a very high grade. And people who were coming from other schools, they had higher grades than these. So in fact, in the initial stages of joining engineering, I was in the wait list. I didn't come in the list of students to be selected for a particular college where I wanted to go. I had to wait. When the wait list started functioning, I don't remember what was my list number, but eventually I got it. So when I got there, then I started working, and I found that because of my education in another kind of school, I could cope better with the other students. And then it was a scene of almost doing better than other students in most of the subjects.
I know that you're working as a lecturer currently at the university, working with engineering students, but can you remember being the student in the lecture hall? Was it more physics and maths focused, or were there elements of other subjects that young people should be paying attention to?
Math and physics definitely is number one to be taught for engineers. Apart from them, what I call the language of the engineer, which is drawing. drawing not the fine arts, but the proper drawing of making 3D drawings, 2D drawings, or perspective views. So that is something which is important for a student to be an engineer in any field, whether he wants to be an aeronautical engineer, where he's involved in manufacturing of aircraft, or be a maintenance engineer. Even in maintenance, when there is a defect on the aircraft, we have to communicate 100% to the manufacturer that these are the defects. So unless an engineer can draw properly, he will not be able to communicate, because words, you'll have to write a book to describe something. But if it is a drawing, in a very short 2 paragraphs, you can explain to the manufacturer what the defects are. So I would say drawing, engineering drawing is something very important. Now, connecting that to mathematics. In mathematics, we have trigonometry and geometry. So if the students are more hands-on with trigonometry and geometry, that will help in engineering drawing also.
What is manufacturing engineering as a specialty? Can you describe that for anyone curious about it?
See, manufacturing starts from the smallest component of a body. Since I'm in aviation, so I would say about the aircraft. So first, the aircraft has to be designed. Now, after designing the aircraft, a model is made, not a full scale, a reduced scale model. And that model would be the aircraft which will fly in the air. Now, in the air, aircraft moves, and we consider the air is stationary. Air also will be moving, but we put it this way, that aircraft is moving, air is stationary. And then what we do is, in a laboratory, we have wind tunnels. So in wind tunnels, we keep the aircraft stationary and the air is moving. And then all the parameters are checked. And there's something called a Reynolds number. Reynolds number for the model aircraft and the Reynolds number for the full-scale aircraft should match. And whatever outcome we get from the wind tunnel tests, that is applicable to the full-scale aircraft. So once that is done, then the manufacturing starts. Now in manufacturing, we need to have the strength of material, the strength of the fuselage, the strength of the wings. Now what material to use to build an aircraft to take this much load, depending on how many seats we have decided for that aircraft, what will be the cargo for that aircraft. And last but not least, what's the range? Will the aircraft fly for a short distance, regional aircraft within the country, or it is going international across the seas? According to that, we have to design the aircraft. And the weight. Once the weight is ascertained and aircraft design starts, then the engine manufacturers are informed that we have an aircraft whose weight is this much and we want it to fly a range of these many 1,000 kilometers. Then they will design the engine. So design of engine is separate, not by the aircraft manufacturer. Aircraft manufacturer, they manufacture only the airframe. Rest of the avionic equipment, engine is taken from other experts, which are called the vendors there.
What would you say are the top strategies that a young person needs to remember if they want to go down this career path?
One of the two, one must decide. Does he want to go for aircraft maintenance or he wants to go for manufacture? Now in manufacture, they need to study aeronautical engineering or aerospace engineering. Whereas for maintenance, students can go even after their schooling. Immediately after school, they can join an aircraft maintenance engineering course, and that course leads them to a license by the national authority of that country or from EASA, from Europe. So European, it's European Union Aviation Safety Agency. So they are for whole Europe, but of course, Brexit, due to Brexit, I think they will be going out. Britain will be going out. and Britain is called CA, Civil Aviation Authority, but definitely they will have a connection. So once a person completes the aircraft maintenance engineering course, which are about 13 modules he has to do, and that course is a very, very structured course. One has to fulfill all the criteria, all the elements of that course, and then 2 years of practical experience in an operating aircraft atmosphere environment. Then he applies to the authority, he gets his license. That's called an engineer's license, Aircraft Maintenance Engineer's License, ML it is called. Once he has that, then he can actually work on the aircraft. After getting this, wherever he's working, that airline will give him something called a type course. The type course is about a particular aircraft. It could be Boeing 777, it could be Airbus 380, it could be Airbus 320 or Boeing 747. Once he does the type course, which is not a long course, maybe 2.5 months or 3 months course, then on his basic license, which he has got from the national authority, his type rating will be endorsed. Now he's become a full-fledged aircraft maintenance engineer.
Wow, so much you've offered us today. It's a wealth of information. Just before we bring it to a wrap, I heard you say an engineer must be alert, using the example from your military experience. An engineer must be having a good attitude at work. And then you said to be able to be adaptable. What else would you tell a young person thinking about this career, either in aviation or even in any other type of, whether it be automotive or any other type of engineering, just going into engineering, what else should they be prepared for?
Patience. Patience is very important because nothing happens fast in manufacturing of cars or aeroplanes or maintenance of cars or maintenance of aeroplanes. Patience is something which people should have.
Thank you for watching, everybody. It was an amazing interview with Sayeed Khan, who is an aeronautical engineer currently working at Emirates Aviation University as a lecturer. He shared his wealth of education, his wealth of industry experience, and lots of tips to help our students understand the world of aeronautical engineering and just being an engineering student as well. Thank you for watching. Thank you for joining us today, Sayeed. And I look forward to seeing you all at our next Desk Careers Digital Spotlight.
Thank you very much. Thanks for having me with you.